Hello everybody, welcome back to my basement. Today I am here to demonstrate how to get Sas started inside Iowa's virtual desktop. So where I am is on this page of the handout, picking up from the last video. So just to remind you where all this stuff is, here's our course webpage. On the day that corresponds to your first homework's due date, I have a handout, which is right over here. That's what I'm working from. And the videos that I'm making today are going to be posted right here. And all of these videos use these files, example 1. So you will need to have watched the first video or followed the steps in the handout up to this point. So we are inside Virtual Desktop. So far we have opened up Windows Explorer inside Virtual Desktop and navigated to where the files are for example 1. So I will note that inside this Windows Explorer, you'll want to go to the View tab and hit File Name Extensions. So this is what it looks like without them. And now you can see what they are, so that makes it a little bit easier to tell which file is which since they're all named very similarly. So that's where we're at so far. And I'm going to go ahead and open up Sas. So I had saved Sas as one of my favorites in the previous step so that I can find it more easily inside the virtual desktop. It does take a few seconds to start, and my Windows security system wants to know what they should be able to do with the files. Please hit Permit All Access, Permit Use, and now the first time that you load up Sas, you will see this box. It is simply a courtesy notice that things have changed in Sas 9.4 relative to older versions. If you're not used to older versions, then this is not helpful to you. But I'm going to click Don't Show This Again, Thank You, and hit Close. So Sas, when it opens up, I'm going to make it big so we can see, looks like this. So the first thing that you may notice is that there are several different windows open within the main window here. So Sas contains several different sub-windows. What we have moving from left to right, this is Explorer, so it functions a lot like Windows Explorer in that it's a navigation system so that you can get to your files in various places. So that's this tab right here. The other tab that's on this left side here is a results tree structure that will appear once you actually run analyses. So it's similar to what the tree structure looks like on the side in SPSS and other programs. Most of the time I don't refer to it though. We'll keep it on Explorer here. On the right hand side, there are 3 windows that open by default. One of those, the first one, is Output. This is where old-fashioned text output used to go by default. That is what they changed as of Sas 9.4. I use old-fashioned text output in building my handouts because it is much easier to annotate, but you shouldn't need it for anything. So the first thing that we can do is close this output window and get it out of our way. Now we're left with 2. The window that is at the top by default is the log. So this is where all messages go with respect to what you ask Sas to do and whether it worked correctly. So blue is good, red is bad. So every time you execute something, we're going to keep returning to the log here to see what happened, read the messages, and ensure that everything functioned the way that we wanted to. One or more libraries does not exist. You can disregard this message. This just has to do with an error during the Sas installation. That was not any of our faults. So I am going to clear this log so that all of the messages start fresh. You can do that using the Edit menu, which is Clear All, or you can also hit keyboard shortcut Control-A for Select All, and Control-E clears the log. So now I have a fresh log to start from. Down here, so the other tab here, this is called Editor Untitled. This is where you'll do your typing. So fortunately, you don't have to type anything from scratch in my class. You can open up the example file that I created for you. So we're going to go to File, and then Open Program. So program is what the syntax file is called. Syntax is where you type. Syntax, I should say. Open Program. So it wants to know where your file is to be opened. I'm going to go to my H drive. Nope, that's not it. Let's go over to this PC. That'll make it easier. So here it is, Les Hoffman on H. That's that one. here is the folder that I downloaded earlier and extracted, and subfolders is noted, and there's only one .sas file in here. .sas is a syntax file, so it's a typing file, and it's labeled as Sas Syntax to try and make that a little more clear. So I'm going to go ahead and open it, and here it is. So I am going to make a couple changes to make sure that this is easier to see. One is to make sure that you can see the line numbers going down the left-hand side that I can see, because that will allow us to easily refer to where we are in the code. To fix that, we're going to go to Tools, Options, Enhanced Editor, and then there are several options in here for customizing. On the General tab, we want Show Line Numbers to be checked. On the Appearance tab, if you'd like your font to be bigger, such as in this demonstration, it will be useful to make this a little bit bigger so it's easier to see. I'm going to blow it up to 14-point font, and there we go. So there's a lot of words in here. Most of what I'm going to say is already written down in comments, but I will go through each of these parts and we will execute the parts one at a time so that you can see what happens. So I'm going to go back over to Explorer here. First thing that I have are just commands that deal with the formatting of your output. I like to see my output in a certain way, so this is at the top of all of my programs. By default, Sas puts extraneous information in your output, such as page numbers, dates, and so forth, so this option statement turns off all extra stuff that it sticks in there. It also eliminates automatic page breaks between output when you're using the old school listing. So you don't need to change anything in here. You can just run this as stated. So I'm going to execute this set of commands by highlighting them. And then up here, there's two ways to execute commands that you have typed. One is the little running man icon, but be very careful when you mouse to the little running man icon because he is right next to the delete icon in the worst human factors decision ever. If you accidentally hit delete, you can get it back by hitting undo, but I'm going to mouse over here very quickly and hit submit. So you can see that the words that are typed here that control what the output is going to look like have been echoed to the log. There's nothing else that happened because I didn't tell it to print anything. I'm simply controlling what the printing looks like. Next, on line 6 here, I have notes. So all of this green text right here, these are what's known in programming as comments. They are notes to yourself that the computer disregards. Comments are essential in creating a program that you will be able to understand later and share with other people. So each of these lines that starts with an asterisk and ends with a semicolon is a comment. And so if I have a comment that spans multiple lines, for instance this one, you are able to put the semicolon at the end and have one asterisk at the beginning. There's other ways to comment multiple lines, but this is the simplest way to do so for now. So I have a note in here that each Sas command that starts with a blue word must end in a semicolon. We'll see that below. Data transformations, so we don't have any of those in this example, but just as an FYI, they all have to happen in reference to a specific data set. So you can't just tell it to make a new variable without telling it where the variable is coming from and is going to be stored. And then last but not least, colors help you in reading Sas programs like this one. Comments are green. Anything that is in blue, like these, are Sas identified commands. Variable names and file names that you would change are black. If you see red, something is wrong. So I will screw a few things up in this demonstration so that you can see what that will end up looking like. Anything that is in a purple color is going to be case and space sensitive. That includes access to file directories within libraries, which is how Sas understands where to find things, as well as labels. And so I will note there is a keyboard shortcut to execute things in Windows. You don't have to hit the running man. You can also hit F3 instead. I want to say that it's F8 on a Mac, but I'm not 100% certain about that. If anybody knows, please drop it in the comments below, as they say on the YouTube. Okay, So the most important step, and the part that everyone has the most difficulty with the first time they do this, is conveying to Sas where the data file is that you're going to be working with. The problem is that Sas has a very easy way to do this only for Sas data files. Whereas if you're new to Sas, odds are good you're going to be wanting to work with other kinds of data files besides just Sas specific ones. So the solution that I've created allows you to refer to a place as your working directory, essentially, the place where all of your things are going to be coming from, and have it work for Sas files and non-Sas files. So I have this note here. These little blocks of comments are separators for my programs, and so sections of the program that are for general tasks I have indicated with these sorts of separators. So here's another one, for instance, for the univariate statistics. So this whole section that follows is about data import, and you must define where your files are. So file save is an abbreviation that the program is going to use to refer to whatever file path folder, file path plus folder, that you have in this, after the equal sign, in this entry. So this is the hard part. The trick to getting this right seamlessly is to use Windows Explorer within the virtual desktop. So back on here, we would start Windows Explorer. This is the window that pops up, and you want to navigate to where you've stored your files. So for instance, right now I'm inside my H drive. Had I wanted to use my own files, I could start with local disk C and then navigate to different places such as my own Dropbox, which is where I keep all of my things. The easiest place that it automatically understands, though, is your H drive, and so that's why I had recommended that people store things there. So I'm going to go to where the specific files are. The data file that we're going to be importing is this one right here. So I'm going to put my cursor in the address bar and watch what happens. It collapses into a link that I can copy. So I'm going to hit Control-C and copy that link. And I am going to replace this address right here with paste what I just found. So make sure that you have an equal sign at the front after this word file save, which again is an abbreviation, a semicolon at the end. Now there's one tricky thing in here. It does not write a colon, it writes a $sign. So I can change that to a colon. If I'm inside the H drive proper, I don't actually need this part in front. So that's interesting why it put it there. Oh, it's because I navigated to it on my own machine. My bad. If I go to the H drive on its machine, so this part down here, then it's lacking that additional prefix. So there we go. Now it's H proper. So I'll show you what that looks like. It is exactly the same. So this is what it would look like. I have an example down here that is commented out. So this asterisk at the front makes it so Sas isn't going to read this, but it's a note that you can use to show what it would look like if you wanted to store your files outside the H drive. So let me turn that on for just a second. So if I wanted to use my own Dropbox file structure, that's fine. I just have to preface it with this. So that's the extra part that causes it to go looking inside your machine as opposed to the servers that it has access to. So I'm going to comment that back out so it doesn't read it. And now I have the H drive. Now down below, I'm going to execute code that imports that Excel file that we'll be using for this example. So Proc Import does exactly what you would think. It imports. What do you want to import? Goes on data file. This part right here is where the file is as defined up above. So it's using this abbreviation. When you see this ampersand in front and period in the back, that means fill in the abbreviation as defined here. So this operates like a find and replace. That way you can refer to this place as an abbreviation throughout your program, but if you wanted to move your files around and put them in a different folder, you'd only have to change it once rather than every time you refer to a file throughout the program. So again, file save is an abbreviation that I have defined as for this place, so the folder where my files are. It then fills in that abbreviation down here to tell it where my example Excel file is, and then I add the name of the file after the slash. The name of the file goes here. So if you didn't change the names of any of my files, this should work exactly as written. The only thing you have to change is the folder that it's pulling this information from. What it's going to be called in SAS is on the outline. SAS data sets have a two-part name. Where is the first part, separated by a period. That refers to a library. A library is a SAS folder. The name of the file to be created then goes after the period. The type of file that it is, this is database management is what it stands for. XLSX is a type of Excel file. There are different options for almost every kind of file under the sun, so you can use this to import SPSS files, data files, access files, text files, all kinds of stuff. Replace means if it's already inside SAS, go ahead and write over it. This is useful if you screw something up and you want to get a fresh copy imported again. That allows you to do so. In Excel, because an Excel file has multiple sheets, you need to tell it which sheet to pull from if there's more than one. And so note this text here is in purple, just like this text that's in purple. This is case and space sensitive, so it needs to be spelled exactly right in order for it to work. And get names equals yes means in my Excel file, the first row contains the variable names. It understands that, and it will read them in as variable names so that I don't have to rename my variables. So I'm going to execute the setting of the abbreviation to where my stuff is. So I'm going to highlight that and hit F3. Nothing happens except that it's echoed up here. That's fine because I'm just setting an abbreviation that SAS will understand. And then I'm going to highlight all of this code right here and hit my running man, F3, and it worked correctly. So note, the import dataset has 734 observations and 10 variables. Work.example1 data was successfully created. SAS is all about building self-efficacy. It tells you that you're successful, and doesn't that feel good? So a couple things here. Now that I know that it's imported correctly, I want to make sure that I save what I'm doing. So there's a little asterisk in the name of the file here that tells me I haven't saved it yet. You don't have to do anything special to save your work. Control S just like normal, or go up to File and hit Save. So save the typing that you're doing here periodically. That way it doesn't get lost. Now, where did my data file go? That's a very valid question. Now we need to go over to my Explorer tab here. So under Libraries, this file cabinet looking thing, I'm going to double click on it. And here's a list of SAS libraries. These 5, I don't even know what they are, and I've never used them. You can disregard. The one that's called Work, though, that's the one that we're going to use. Work is an automatically created temporary place that we are going to import all data files into. It dies at the end of our session, so the data files that we create are not going to be saved, but that is actually what we want, because all we need to duplicate our work at another point in time is this program that we're typing in and the original file in its Excel format. We do not need to save the SAS data file. So it's stored in this temporary location. The Excel file is safe and sound. Nothing is going to touch it, which is how we want it. And if I double click on Work, here's my data. And you can double click on it and see what it looks like. So this is a typical file format for doing statistical analyses. Each row is a separate person, and each column is a separate variable. So each of these variables then have names that are at the top. This is how you tell SAS that you want information for these particular columns, these names right here. There are more columns in here than we're actually going to work with for right now, but that's okay. That's often the case. You can tell if these columns are stored as numbers, like they're supposed to be, if they are right aligned. If you ever try to import a data set and you see numbers that are left aligned, that means that Sas thinks the number is actually a text variable instead, and you cannot work with it as a number. I can help you fix that if you're ever in that situation, but the data sets that come from me, I guarantee will be imported correctly for all of our sanity. So unlike SPSS and some other programs, you cannot have the visualization of the data like we have here open while you do stuff to it. It will yell at you. So I'm going to close out of it by navigating very carefully over to this X. So we have like 7 windows open at the same time. Hitting the right X can be tricky. So you can either carefully navigate to the X, or down here where it's listing that tab, you can right click on it and hit close. So I tend to go down here and right click, that way I can make sure I'm hitting the right X. Okay. So our log is waiting for us to do something. Our syntax file is waiting for us to do something. The next piece that we need to work through, so note that I'm not changing anything, right? The only thing that I changed to make this program work was right here. The rest of it should work exactly as it's already written. I'm just going through it step by step to talk about what each piece does. Proc format. This is a way to create a dictionary for each variable as to what the numbers mean if the variable is actually categorical. So what I'm creating within this proc format, so all procs have the same structure, proc whatever, stuff, run. So like a sandwich, as I said in class, here's the bread, here's the toppings or meats, cheeses, etc., and then here's the other slice of bread. This one is creating 2 labeling conventions that is being stored within Sas's memory here for how we would label variables with this information. So F marital right now is a labeling convention I am defining as such, where if I see a 1, it means 1.married. If I see a 2, it means 2.widowed, and so forth. So this is the variable that we looked at in lecture 1 as an example of a nominal variable, because these are marital categories that are not ordered. Likewise, I'm creating a naming convention, a labeling convention called fhappy. The F, by the way, stands for format. The way that I tend to name things is I put F at the front if it's a format labeling convention, and then the variable I intend to apply it to goes as the rest of the name. You can name it whatever you want. It's just easiest for your own sanity if the names actually mean something to you. So there's a variable in the data set called happy. I am creating a labeling convention for it with adding this F in front. So the labeling convention is named fhappy. And this is an ordinal variable. I believe we looked at this in lecture 1 as well. So there's 5 categories. So you might be wondering why I have the number in 2 places. So for instance, I have 1 equals and then 1.unhappy. The reason for this, if I were to not put a number in here, for instance, if I just did that, when I get my output for how many people are in each category, it will reorder these labels to be alphabetical. So even though the first answer possibility is number 1 for unhappy, it will put unhappy last because it starts with U. So this can get very confusing very quickly. To prevent that, I always put the number in the front so that the output remains in the same order as the original numbers used to represent the categories. So I'm going to execute this little piece right here. And again, nothing happens except it prints to the log that these labeling conventions have now been saved inside Sas. Next up, working with data. So in this example, I'm not requiring you to make any new variables. I'm simply adding labels and labeling conventions for the values of my categorical predictors. So all of the homework files that you will be doing this semester we'll have a starter syntax file like this one that includes labels and things so that you know exactly what you're dealing with in terms of the variables. So I have comments here that indicate what these commands are doing. But in general, all actions that pertain to a data set, to make new variables or recode variables or select cases or things like that, will require these two things at the front of them, data and set. So what is actually happening in terms of Sas is it's saying data means make me a new data set. It's making a new data set in the work library, so this same temporary directory, it's being called example1. What am I making the data set out of is from the set. So the word set means from. I'm making my new data set from a data set in the work library, also called example1. In other words, this is Sas language for save as itself. So I am taking my current data set, I am changing it by adding this information, and then I am saving it under the same name. If I wanted to make a new data set, I could do so. I would have to change the name on data because that refers to how it's being saved. So if I wanted to do something like example1 version 2, for instance, then it would start with this data set, do these things to it, and then save the result under a different name. In general, that won't be needed unless you're doing radical things to data that you may want to keep a separate version stored for. So we'll leave that there. So all I'm doing in here is adding variable labels and value labels. So a variable label is an extended text string that will print on your output anytime you ask for something related to that variable. So for instance, marital is the name of the column. So if I reopen the data to show you, marital is what the column is called. So if you want to tell Sas to do something with this column, you refer to marital. But for your own sanity and for transparency of anyone else who's working with the data, you can tell them to add this text string to the variable that marital is 5 category marital status. Likewise, happy is 5 categories self-reported happiness, and income is the other variable we're working with. That's annual income in thousands. So this just adds additional information to your data that shows up in your output to better describe your variables. Format is then telling it to apply the labeling conventions that we defined up above. So it's saying, you know that column called marital? Apply the labels that I defined as F marital. Likewise, that column called happy, I want you to apply the labels that I defined up above. So I don't need to change anything. I'm going to highlight all of that, and I'm going to hit run. Now let me break it to show you common mistakes that people forget. So forgetting semicolons, for instance. If I forget a semicolon right here, note that the next line turns black because it doesn't understand that you're done with this set command. It thinks you're still going, and it will try to find data sets that have these words in their title. So if I hit a semicolon, then the comment is green like it's supposed to be. Likewise, if I forget a semicolon at the end of a comment, so I'm going to take this one off, watch what happens to the colors of the next line. Everything turns green because it doesn't understand that the comment is over. It's going to think that all of this is just a comment until it hits a semicolon. So if things are the wrong color, check for missing semicolons as a possibility. Another common mistake that people make is not understanding that label is one command that is terminated by one semicolon. You can include 3 different labels within one command. But let's say that I forgot about that and I accidentally put semicolons at the end of each line. Looks fine, right? If I run this data set, watch what happens to the log. Okay. It's very angry with me. So nothing is red, but it keeps saying error, 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 error. Here's why. With the semicolon at the end of this command right here, that shuts off label. From this point forward, where I have happy equals and then a semicolon and income equals with a semicolon, it thinks that I am making new variables that are only words. So that I'm trying to define a new variable happy that is equal to these words and a new variable income that is equal to these words. This is not what I want. So I'm going to fix it by removing these extra semicolons that I added. But if I rerun this, it's not going to work because I've already rewritten this happy column and this income column. So if you find yourself doing something to a data set that screws it up in this way, I'm going to clear the log so that we can see all those error messages go away. That's Control E again, by the way. You can fix it by rerunning the import step. So if I go back up to this section, line 28 here, and rerun that, now I get my fresh, correct data set back again over here, and I can reapply. I don't need to rerun the formats, but I can reapply this step that should be now executed correctly. So I'm going to save my work. I'm going to show you what happens in example 1. So now that I have applied the labels and the labeling conventions, the variables that have been labeled now have that label in the top here. So those 3 are the ones that we added labels to, and the ones that were categorical that I applied labeling conventions to the values now have those values printed. So when we use these variables in analysis, you'll see these labels rather than the numbers. By the way, if you want to just see the variable names, there's an option under View. Right now we're looking at column labels. If I switch to column names, then you can see what it is actually called. Because you can't see both at the same time, let me switch back to labels. That is why in my labeling conventions, I start with the name of the variable and then a colon and then the label. That way I can actually see both at the same time if I were to view the data. So closing out of the data set again, I have a note here now, example 1 is ready to use. So just to recap, all we have done so far, I'm going to make this a little bit bigger, control what the output looks like. I have notes in here about colors. That doesn't do anything. The most important step, tell it where your stuff is. So this came from Windows Explorer within the virtual desktop, putting my cursor in the path here to copy the path and pasting it in here, starting with an equals, ending with a semicolon. That's the important step. Once it understands where your stuff is, then you can run the rest of this without changing it because it's referring to existing files as they are currently named. So we imported the file, we created a set of labeling conventions for the categorical variables. We then added variable labels to our data set and those labeling conventions so that our data set has all of the information in it that we will use in analyses. So moving on, I have a block here, changing gears. Begin example 1, univariate statistics. So in lecture 1, I showed you snippets of code and pictures of what the output would look like. I want to now show you where all that stuff came from. So this is another section where you do not need to change anything to run this program and see what happens. So first note here, title. So all of these little routines start with title. This is a descriptive label that will print to your output. You do not have to have it, but I highly encourage you to have it because that way you can easily see what you asked for and why. So I have here Sas, that way we can differentiate each program when I have handouts, frequency table, and plot for categorical variable marital. So Proc Freq is how you get descriptive information for categorical variables. Freq stands for frequency. First question, where are the variables coming from? Data equals work.example1. So example 1 is what we named the data file when we imported it right here. And everywhere else in the program, it refers to example 1 as the name of the file. You can change it up here if you want to, but then you'd have to change it in every single place that follows. So example 1 is what we're calling this. It's stored in the work library. Its name is example 1. Okay, so now Sas understands that I want frequencies. I want it from the data set called example 1 that is stored in the work library. Now, which columns do I want frequencies for? That is conveyed by table. Which columns do I want tables for? Right now, only one, marital. I can get that. If I wanted to have it for more than one, I could do that as well. So I'm going to add happy to the list just to show you what that looks like. And as we discussed in class, missing means if anybody's missing information, make sure they go in the table too, so I can see how many cases don't have an answer. And then plots is going to give us bar charts in percent for how many people are in each category. So I'm going to highlight that part. You can highlight the whole thing. It doesn't matter because these green lines again are just notes. Sas will disregard them. They're only for you, so you can include them or not as you wish. And I'm going to highlight that, hit F3 or navigate to my little running man and see what happens. Now a new window pops up. So now we have a log which tells us that it wrote a new file and that the frequencies used this data set, so all is good there. We still have our file that we're typing into. The sign means that I need to save it. I'll go ahead and save it. And then results viewer is where our stuff is going to go. So it printed a new window here that has a frequency table. So this is as shown in lecture 1. So each category is in order in the rows of this table. And again, note the numbers because otherwise the rows would be in alphabetical order instead. The frequency of people in each category, the percentage of each people in each category. So for homework 1, you'll need to convert these to proportions by moving the decimal over to the left 2 places. Cumulative frequency, which is not really meaningful for a nominal variable like this, but it does tell you how many people are in your data set. That's always question 1, is how many people do you have? And it makes this plot. Because I added another variable to my example here, happy, it made tables and plots for that one as well. So here's the frequency of people who responded in each of my categories for happy, and here's the picture that it made. So what if you want less output? You don't want the plots, for instance. This is where comments can be used strategically to limit output to just what you want to see. So note that the end of this command has a semicolon. That closes this line, so it understands it's done making tables and figures. But if I don't want the figures, here's what I can do. I'm going to preemptively shut the line off by adding a semicolon right here. And now note the rest of this is black because Sas doesn't quite know what I'm trying to do here. I'm going to put an asterisk in front to turn it into a comment. So what I have done is leave this code here for my future reference in case I want to use it. But now when I run this, it only gives me the 2 tables. So you can control how much output you get by turning parts of it off strategically by turning it into a comment. Okay, next one. So Proc Freq is to get descriptive information for categorical variables. Proc Univariate is to get descriptive information for quantitative variables, where the numbers are numbers, or otherwise known as interval variables in most cases. So I have a title here indicating to myself what it's going to be doing. You can write whatever words in here you want. Proc Univariate is the command. Again, first thing Sas wants to know, what data set am I using for this? It's work.example1. Var is which variables do you want me to summarize? In other words, for what columns would you like Proc Univariate to give you information? And this time I'm going to use the variable that is income. This is our quantitative variable we used in example lecture 1 as well. And I am making a picture for it. So histogram makes a binned value bar chart, essentially. It's a bar chart where the quantitative variables are rounded into categories temporarily. And midpoints controls the binning of the values. So 0 is the first, 70 is the end, and I want it in increments of 5. Title then shuts off this title. So this prints these words this title shuts it off. If I didn't have this, it would keep printing these words for every single thing I do after that, which defeats the purpose. So I'm not going to change anything right now. I'm going to highlight that and run it. Here's my picture. If I scroll up, here's all of the output it gives me, quite a bit. But everything you would want to know about a quantitative variable is going to be in one of these tables here. So mean, standard deviation squared is variance, mean, median, mode, for instance, interquartile range. And then the quantiles themselves, as they're often known, it gives you a bunch of them. Note that 50% is the median, cough, cough, homework question. 75% versus minus 25% is where the interquartile range comes from. And with options, you can ask for more stuff too. And it also tells you about the most extreme observations in the context of data checking. So let's say that I wanted to get all of that information, but I didn't want the picture. In this case, the picture is created by just this line alone. So if I don't want a picture, comment it out. And then if I run this again, you'll see that I don't get a picture, I just get the tables. And proc means is a quicker way to get descriptive information, but there's less information provided. So proc means is structured the same way as proc univariate, although it doesn't have options for pictures. So proc means what data set you want, what columns you want, which is just income, and I can add other variables here as well. So I'll add happy, for instance, to show you what it would look like to summarize that, pretending that the numbers are numbers. This is number of decimal places, so you can control the level of precision printed to your output, which is nice if you intend to make tables for manuscripts, for instance, and you want to show it all consistently at the same level of precision. These keywords here ask for what I want means to show. Without this one, var, let me remove it for a second, this is what you get by default. But because I wanted to show variance in addition to standard deviation, I had to write all of them. If I only wrote variance, I'd only get variance. So I have all of these things here. So I will run this little piece to show you what that looks like. And now at the bottom of my results window is this very compact little table. It has both of the variables I asked for, sample size, mean, standard deviation squared is variance, and the minimum and maximum. So this is a more succinct way to get descriptive information. Most of my handouts use that because rarely do I need more information for descriptive purposes than just that. And here's another example of what I would do with univariate to make a histogram. So this is structured the same as up here. So that's it. That's everything that I wanted to show you with respect to the syntax and how it works. So again, to execute something, highlight it and hit the running man or F3. And I would strongly encourage you to get in the habit of executing something, check the log to make sure that it's blue, and then see what you got. If you don't get anything new printed to this window, chances are you screwed something up and the log will tell you about it. And if you can't figure out what you did wrong, take a screenshot of what the log is saying and what your code is saying and send it to me and I'll help you troubleshoot, because if there's a mistake to be made, I've probably done it before. So at this point, I've saved my work in the syntax file. I could close out of Sas and everything is fine. All you really need to save is this syntax file and the original data file that we imported in Excel format. And if I were to reopen Sas, I could just re-execute all these commands and I'd be right back to where I left off. However, if you want to save your output and complete homework later, for instance, you don't want to do everything at once, but you don't want to have to log back into Sas, there is a way to do that. So the very last thing I wanted to show you down at the bottom of the program here, bonus code to save output, is a 3-part set of commands. It's open an external file. You would then execute whatever commands you want to save and then close it. So this is sending to that same file save abbreviation place a new file that I have named example1 Sas output, and it's going to be saved as a rich text format so that you can open it in Word or any other text editor. I'll note that I already made this for you. It's right here. So you can see what, if I had just executed the code straight up and not messed with anything, it would have looked like. But if you're somebody who really likes to save your work, then I'll show you how to do this. So for instance, if I wanted to save this Proc Univariate, let's copy it, put it down here. So if I run this, what this part does is open up the file. It then generates whatever output is going to be in the file, and then the file gets closed. So let's see what happens if I execute this whole thing. On my desktop, the file pops up. Okay, it's worried about content, that's fine. I would like to unblock and see it, and there it is. So it looks like it opened in WordPad on this device, and you can then save it to wherever you like, but it is already saved in this H drive place. So that's what I did, basically, is just redo this. And that's what I asked for. Here's the results of my my process. And that's it. So you don't have to do this, but because so many people like to save their output so that they can refer to it later, I wanted to show how to do it. So that's the end of the demonstration with respect to example 1. I'm going to save my work here and show you one more thing. So you are going to get, for each of your homeworks, starting with homework 1, what I call a starter syntax file. So this isn't available yet. I'm previewing it here within this video so that I can show you what you'll be doing with it. So here, for example, this is in a text file. Let me see if I can make it any bigger. Nope. So this is a starter syntax file for homework 1, for instance. So this needs to be updated for this year, but this is the homework assignment that I will be giving you in this class. So on the homework portal, you will be able to open up this file and it will print to a web page. This is Sas Syntax. This is doing the beginning steps of defining where your stuff is, importing your homework data, creating labeling conventions for any categorical predictors, and then applying variable labels to your data set. It also has a start to let you save your results. So start the file here, put your models or output to be generated here, and then close. So when I give you one of these starter files, here's what you're going to need to do. Step 1, copy. Select all, copy. Now in Sas, the easiest thing to do would be to create a new one of these typing windows. So I'm going to do that by making sure my cursor is here inside the current one. That way I get the right set of menu choices. File, new program. It opens up another typing window. I'm going to paste the file that we were just looking at in here. And now you can see that it is indeed a Sas file. So what I will do first, note that it's not saved currently, is save it as, and the easiest place to put it might be in the same place where my example is. So I might call this homework 1 syntax instead, for instance. To be able to import your homework, I'm going to make this big, file save. That's the key. So tell it where your stuff is. So in order to do that, if I had my homework data set stored in this same folder, again, go to Windows Explorer, copy it, paste it. The next step is a Proc Import for your homework data. So my ID number that I use for my dummy login is this one. You will change it to have it to be yours, and then it will be saved as homework 1. So once you change this right here, the one line here, line 7, the rest of this you can just run. You don't have to change anything. This is me giving you the labeling conventions that you need. This is me giving you the variable labels that you need, and you can put your code here. So what goes down here then to complete your homework is exactly what I gave you in the corresponding example. So in homework 1, you're going to be generating descriptive statistics. just like the ones that I just demonstrated. So coincidentally, what you would do is go down to where it says univariate statistics, for instance. I'm going to copy my frequencies and put it here where it says your code goes here. So in homework then, your task will be to change this code to work for your homework data. So for instance, I know that my data set right here on this out statement, the data set that would be imported for homework is going to be called homework 1. So that would be the first thing that I change. I'm not doing analyses for example 1 anymore. I'm doing them for homework 1. So I have a 1 like that. Also, these are variable names that correspond to example 1. You would need to change them out for variable names that go with homework 1. So right here on your homework starter file are all of the variables that are included in their names. So for instance, if you wanted to know something about gender ID as a question, if I asked you for frequencies for that, for instance, you would take gender ID, and instead of the example 1 variables, you would put it here. So 2 changes: the name of the data set, the name of the variable. And if you want to, you can update the name of the variable here as well so that everything is consistent in your code. And so now it understands that it wants to use this data set with this variable. So after you've executed all of this code, you will be able to do analyses for this new data set. So this is the process that you will go through this semester. You'll start with whatever example that I've given you as to how you do various things. You will copy that example, paste it in your own file, and modify that example to do whatever you need to do for your homework data. And I will point out that on the course website, for each subsequent assignment, it tells you which example files you should refer to. And they are the same numbers. So I've set up the units to correspond to the homework. So for instance, homework 1 that's due on the 7th is going to be using example 1. Homework 2 that's due later in February will be using example 2 that we're going to be starting in class today as I'm recording this video. So make sure that as you're typing, you save your work frequently, because this is connected remotely. If somehow your connection were to be broken, you might lose your work. So just keep saving the files that you're typing into repeatedly. That way you have everything that you need. So when you decide that you're done, or done for now, and you've saved all of your typing, you don't need to save anything else. You can just hit the X to close out of Sas. It says, "Are you sure you'd like to close Sas?" Well, yes, thank you, I would. And then you're back to where you started. So then to go back in, you would need to log back into the virtual desktop, and links to that are in several places. There is a link right next to the homework portal up here, for instance. There's also links down below when I talked about how to access each of the programs. So that is it for now. Thanks for joining us, and I'll see you on the other side.